All right, hello everyone. So this is my showing you some of the solutions to the 2.3, 2.4 worksheet. So I'm going to start off with 2.3 and we are going to look at number 4, which asks us to find the slope given 2 points. So the first thing I would like to remind you of is the formula to find the slope given 2 points. So the formula is y2 minus y1 x2 minus x1. Said is that slope is the change or difference in the y values divided by the change or difference in the x values. In 2 points, the first thing I'm going to do is label them. So I'm going to call point 1 x1. Hold there, it goes. x1. I don't know what the heck is happening. Okay, x1 and y1. I'm going to call point 2 y2. Once I get the points labeled, I'm going to plug them into the appropriate position. So y2 I'm going to replace with -3 minus y1, which is -1, divided by x2, which is -2, minus x1, which is 4. We have a double negative, and the opposite of a negative becomes a positive. So I have -3 plus 1. I have -2 minus 4, which is -6. 3 plus 1 is -2, so I have -2 divided by -6. The last thing we're going to do is see if we can simplify or reduce this fraction. So I can divide both the top and the bottom by -2. -2 divided by 2 becomes 1, and -2 divided by 6 becomes 3. So the slope of the line, given the points 4, -1, and -2 and -3, and the next question asks us to write the equation of a line given that m is equal to -1 and the y-intercept is 2. Since they don't specify, I'm going to use slope-intercept form because those are the two things I'm given. Slope-intercept form is y equals mx plus b. So I'm going to look at what I'm given, and I'm going to replace m, or the slope, with -1. I'm going to replace b, or the y-intercept, and if you leave your answer like this, it's okay. Necessary to write -1 times x. So I'm just going to replace the -1 times x with -x plus 2, and I am done. Given the slope and the y-intercept, I have now written the equation of a line. The next question, number 13, gives us a graph and asks us to find the slope. So here's the y-axis. I'm going to look along the y-axis and figure out where the line crosses. And I see that that happens at 2. So the y-intercept is 2. However, most of the time, they'll want the answer as a point, 0, b, which in this case is 2. So my answer to the intercept is 0, 2. Slope, we're just going to count squares. Again, a reminder that slope is the change in the y values over the change in the x values. So I'm going to look along my line and find another point that intersects the box. And it looks like we'll be good right here. And then I'm going to count squares. So to get from one point to the other, I went down 1, 2, 3, 4. I'm going to write -4. The x value was right 1, so I'm going to use a positive 1. -4 divided by -1 is just going to be, so the slope is -4, and again the y-intercept is 0, 2. Hey, these next few ask us to find the slope and the y-intercept of each line. Start with number 15. Hey, I personally think it's easiest to find slope and y-intercept if it's in the form y equals mx plus b. Because m, the number attached to x, is the slope, and then b is the y-intercept. So if you look at what we're given 3x minus 4y is equal to 12. The goal is to try to isolate the y. So I'm going to take this 3x and I'm going to subtract it to the other side. And I'm left with negative 4y is equal to negative 3x plus 12. I then have this negative 4 times y, so I'm going to divide by negative 4. And if I divide one thing by negative 4, I have to divide everything by negative 4. Negative 3 divided by negative 4 turns into a positive, so I have 3/4 x. 12 divided by negative 4 is negative 3. In the slope-intercept form, I can easily identify that the slope is the number attached to the x, so 3/4, and the y-intercept is 3, 0, 3. When we look at 17, this is kind of a tricky one. The goal is for you to recognize that f of x is the same as y. So I'm going to rewrite this as y equals 5/4 x plus 7. And if we do that, we can look and see, okay, so 5/4 is the slope, and 7 is the y-intercept. 16 and 18, I don't know if we've talked about yet, but I was hoping that we could kind of use the graph to help us. So y equals negative 2. Negative 2 along the y-axis, and I'm going to put a point. Y-equal graphs are always going to cross the y-axis. Horizontal line, oh that's loud. Horizontal line that goes through. If you draw your little person walking left to right, you can see that this has a 0 slope. What we do is say, okay, we talked about slope being the change in y over the change in x. If you look at one point to the next, we did not go up or down. We did go to the right one, and 0 divided by 1 is 0, or the slope is equal to 0. For the y-intercept, they kind of just give you that y is going to cross at negative 2, so the y-intercept is the point 0, negative 2. So that leads us to, the last page, which is to look at x equals 5. So x equals, this time I'm going to come to the x-axis. 5. And x equals is going to cross the x-axis. So x equals is going to have a vertical line. We said had a horizontal line. If I try to draw a person, it is not possible to walk along this line left to right. So we say that it has an undefined slope. But again, if you look at our change in y over our change in x, to get from one point to the next, y traveled one space. But we did not move left to right. Cannot be in the denominator of a fraction, which algebraically tells us that the slope is undefined. If we're given x equals, we are not given a y-intercept. If you look at the graph, we have a vertical line that goes through 5. It never crosses the y-axis. Y-intercept. Ask us to graph, so I'll start with 21. 4x plus 3y is equal to 12. I see a 4, a 3, and 12, and I notice that 4 and 3 are both factors of 12. I also notice this is in standard form. Graphing in standard form using intercepts. So I'm going to start by finding the y-intercept, and the way we do that is to let x equal 0. And if x equals 0, that whole piece just kind of disappears. So I'm left with 3y is equal to 12. And if 3y is equal to 12 and we divide by 3, then that tells us that the y-intercept is 4. So I'm going to come to the y-axis, I'm going to find 4, and I'm going to put my first I'm also going to find the x-intercept. And to find the x-intercept, we let y equal 0. Pretend that the y is not there. I'm going to get 4x is equal to 12. And if 4x equals to 12, that tells us that x is equal to 3. So on the x-axis, I'm going to find 3, and I'm going to put a dot. At 2 points, we can draw a line. Okay, so I'm going to come, maybe this will help my lines look a little better. I'm going to draw a line that crosses through those 2 points. My arrows to say it keeps going on forever. And we now have graphed number 21, again, standard form using the x and the y intercepts. Which leads us to 22. 22 is x over 3 minus y over 6 is equal to 1. This is also in standard form, so we can use intercepts. I'm going to find the y-intercept, x equal to 0. So if the x piece disappears, I have negative y over 6 equals 1. By 6, so I'm going to multiply by 6. But I also want to get rid of that negative, so I'm going to multiply by a negative 6, which makes this a positive y. So what I do to one side, I'm going to come to the other, and I get a y-intercept of negative 6. I'm going to repeat the process, but this time I'm looking for the x-intercept, which means we're going to set y equal to 0. So the y piece we can ignore. Divided by 3 equals 1. By 3, so I'm going to multiply, and that gets me x is equal to 3. So along the x-axis, 3. Once I get 2 points, I can go ahead and try this time. I'll use double arrow. Check them. And not the only way to do this problem, but if you're given standard form and you would like to tackle finding intercepts, I wanted to remind you of that. All right, so the last one here is 23. U negative 3/2 x plus 1/2. Okay, so it's not going to be perfect. However, this time we are in y equals mx plus b. And when graphing y equals mx plus b, the first thing we're going to identify is the y-intercept. And if you look at the picture, b is the y-intercept, which in this case is going to be 1/2. So my graph is not going to be perfect unless I decide to count by 1/2. So I'm just going to do my best and kind of try to find 1/2 and put my first point. Second thing we do is we use the slope. Slope is which is the negative 3/2. So again, a reminder, slope is the change in y over change in x. So the negative 3 says that we are going to go down 3, and the positive 2 tells us we are going to go to the right 2. So from my y-intercept, I'm going to go down 1, 2, 3, and to the right 2. Notice that we are still green. I can do it one more time. 1, 2, 3, to the right 2. Once you get 2 or 3 points again, I'll come and I'll grab my line as to connect them to form a straight line. All right, this time, I think we're moving on to 2.4. Slope and a point. So a reminder, point slope form is y minus y1 equals m minus x1, where x1 and y1 are points and m is the slope. So if you look for starters, they give us that the slope is 2. So I'm going to have a y something equals 2 times x something. And then they give us a point. So I'm going to call 2 my x1, and I'm going to call 1 my y1. So I can now replace y1 with the number 1, and I can replace x1. I have now written the equation of a line in point-slope form, given the slope and given the point. This time we're going to write in point-slope form, which is again y1 equals m times x minus x1 and 2 points. So if you look back in our notes, in point-slope form, there are two things that we need. We need a point, and we need the slope. It gives us points. So the point we have. What we don't know is the slope. So the slope is what we need to find. So we're going to go back to what we did in the first problem. To find the slope, we're going to use our y2 minus y1 divided by x2 minus x1. And I'm going to label my first point, I'm going to call it x1, y1. My second point, I'm going to call x2, y2. Again, what we know. So instead of y2, we're going to place with negative 3 minus 8. X2 is negative 2 minus 11. Negative 3 minus 8, 11. And negative 2 minus 13, or sorry, minus 11 is negative 13. Now we can't simplify those fractions, but we can divide them both by negative, and double negative is going to give us a positive, so the slope, or m, is 11 over 13. So when we have a point, the final step is just to plug it into our formula. So my final answer, I'm going to take y minus y1, which is 11, equals the slope, which we said was 11 over 13, times x minus x1, which is 8. If you label your points backwards, you could have found the same slope, but used the other point. So if you said y minus negative 3, which turns it into a positive 3, 11/13 times x minus negative 2, which again turns into a positive 2, you also would have been correct. Okay, I'll take either one of those answers. Almost done. So this says first standard form. So standard form was ax plus by is equal to c. Means I need to take my x's and my y's and put them on the same side. As it is, we have y equals 3/2 x minus 1/2. Take this 1/2 and I need to move it to the other side. The way I do that is subtract 3/2 x. 3/2 x from one side, right, it's going to cancel. So I have to subtract 3/2 x from the other side. And that gives me negative 3/2 x equal to negative 1/2. And that takes care of standard form. If that's all the directions said, we would be done. Also say that we need to write with integer coefficients, which in summary means no fractions, no decimals. If you look at the denominator of our fraction, we have a 2. So if I want to get rid of that denominator, I'm going to multiply by 2. The 2's are going to cancel, and I'm left with negative 3x. But if I multiply one piece by 2, I have to multiply every piece by 2. So the positive y becomes 2y. Y equals negative 1/2 times 2. Again, the 2's are going to cancel, and I get negative 1. And I have now taken care of the integer coefficients. So standard form, x's and y's on the same side. Integer coefficients just means we get rid of our fractions, or decimals if we happen to have decimals. And this time, find the intercepts and then graph the line. We have x is equal to negative 4. So we said to find the x-intercepts, just like before, we're going to pretend that the y doesn't exist. Way, then x equals negative 4. This does not look like a 4, so let me help you out. So on the x-axis, we're going to come find negative 4. To find the y-intercept, we're going to let x equal 0, or ignore it. So 3y is equal to negative 4. So y equals negative 4 over 3. So on the y-axis, here's negative 1. Negative 4/3 is just past that. We're going to do the best we can to connect them. Oh, that is so bad. I guess that's all right. All right, we're going to connect them. Now, if you look at the answers write the intercepts as ordered pairs. So if we ever want to write the x-intercept, we said y is 0, so we get the point negative 4 is 0. And we said over here that x was 0, so we get 0, comma, negative 4/3. All right, so we're on to the last few. So this time we're given a point, 7, 1, and we're given to find the line perpendicular negative x plus 3. I would also like you to pay attention to the directions. The directions say slope-intercept form. So our answer should be in the form y equals mx plus b. It's the first thing I'm going to do is find the slope that we're given. So y equals negative x plus 3 tells me that the slope of the line I'm given is negative 1. I have to find the perpendicular slope. There's no fraction. You may want to turn this into a fraction by dropping a 1. So negative 1 is equivalent to negative 1 over 1. If we flip 1 over 1, don't we still get 1 over 1? Perpendicular slopes are opposite reciprocals. So reciprocal comes from flipping the fraction, taking this negative slope and turning it into a positive slope. Now we really don't need 1 over 1, so I'm going to replace that with 1. I am their slope. We're also given a point, so we're going to use point slope form. Minus y1, which is 1. If you need to label, here's my x1, 7, and my y1, 1. That equals 1, which is my slope, times x minus 7. Directions said that we could write in any form or point slope form, we would be done. However, we have to get it into y equals mx plus b. The first thing we're going to do is we're going to distribute the slope. So it doesn't really matter because it's a 1, but for purpose of procedure, I guess, I'm going to multiply the 1 and I get y minus 1 equals 1x. And then the second thing we're going to do is move the y1. It's minus 1, so I'm going to add 1 to both sides. So I get y equals x minus 6, and with that one. All right, so the last one gives us a point and asks us to find the line that is parallel. So again, I'm going to write what I'm given. Y equals 3x minus 2. And I'm going to identify the slope. Is 30. The slope of parallel lines are always the same. The first line we're given is 3, then the slope of the parallel line is also 3. And just like before, we're going to write it in point. So I'm going to take y minus, I'll go ahead and label, I've got an x1 and a y1. So I have y minus 9 is equal to 3 times x minus 2. And again, if it said point slope form, we'd be done, we could circle our answer. But it says slope intercept form. So again, the steps of slope intercept form, the first thing we're going to do is distribute. So I'm going to take that 3 and I'm going to multiply it through. Get y minus 9 is equal to 3x minus 6. And the last thing we have to do is our y1. Here I have a minus 9 to both sides. So my final answer is y equals 3x Again, notice that the slope of the line we ended with is the same slope as the line we started with. The reason is because we're looking at two parallel lines. And we are now 10.